Use the prime factorization of 1200 to find how many factors it has. Okay, so first thing I'm going to do here is write out the prime factorization of 1200. And then you can figure out, once you have the prime factorization, you can figure out the total number of factors by doing some operations on the exponents in the prime factorization. So first, let's just keep dividing this by things. So this is equal to 100 times 12, which is equal to 2 times 5 times 2 times 5 times 2 times 2 times 3. So that's 2 to the 4 times 3 to the 1 times 5 squared. Okay, so the way we're going to figure out the total number of factors is we're going to keep in mind that any factor, any distinct factor, we're going to choose between 0 and 4 of the 2's, between 0 and 1 of the 3's, and between 0 and 2 of the 5's. So I need to figure out how many combinations of essentially these exponents I can possibly make, where the first exponent has to be between 0 and 4, this one has to be 0 or 1, and this has to be between 0 and 2. So the number of factors will then be equal to, well, how many different numbers between 0 and 4 can I choose? There are 5 numbers. I can, the number of, if I want any distinct factor of 1200, it'll have some number of multiples of 2. And that number is going to be between 0 and 4. So there are 5 possible powers of 2 that I can get. I can either choose a 3 or not choose a 3. So that's another 2 choices. And I can either choose 0, 1, or 2 5's. So that gives me 3. So this gives 30. Yeah, this is really just a case of knowing, once you have the prime factorization, how to look at the exponents and realize that it basically boils down to a pretty simple combinatorics problem where, this is why the prime factorization is useful for a problem like this. If it didn't say, if the question didn't say how many factors of 1200 are there, the sort of first thinking to do might be to just write out a bunch of numbers and their corresponding divisor of 1200, like 1, 1200, 2, 600, 3, 400, and so on, and then just count them up in pairs. You would have 15 rows in that thing, and it might be difficult to actually figure out. You might miss one by accident. So it's a lot easier to just write out the prime factorization, and considering how many zeros there are at the end of this number, it's pretty easy to just do the division in your head like this. And once you have these exponents, just realizing that any factor basically comes from a unique combination of the choices of each of these things, you can pretty much just count them up like this. Yeah, so nice, quick little problem. Don't really have much more to say about it, so thanks for the submission, and thanks for watching.